In 3.3a, I'm going to show you how to solve linear systems by the third method called linear combination. And here's the steps if you want to jot these down. The first step says you're going to multiply one or both equations by a value so you're trying to get it to be like 3x and negative 3x, for example. Step 2 says add the equations from step 1, combining the like terms, and it will eliminate one variable. Then you're going to solve for the remaining variable. After you solve for the remaining variable, step 3 says substitute the answer that you obtained in step 2 into either of the original equations and solve for the other variable. After that, you'll have the answer, so step 4 will say check the answer in each of the original equations. Let me show you exactly what these steps mean. So when you look at this system right now, what the main goal is to do this is they want you to actually add down vertically. So you would add your like terms. So I would say 8x minus 2x is 6x. Then I would say 1y plus 3y is 4y. And then 12 plus 10 is 22. Now that's what we need to do. However, we only want to do that when either the numbers or the coefficients in front of the x's on the two equations are the same numbers but different signs, or if the numbers for the y's are the same numbers but different signs. Because what we want to happen is to have one of the variables to cancel out and be gone. We want either the 6x to not be there or the 4y to not be there. So let me erase what I just did and let's look at this from a strategic viewpoint. We have a variety of choices in this problem. We can choose if we want to isolate and get the x's out of there or the y's. If we want to get rid of the x's, right now I have an 8x and a negative 2x. We want them to become the same number. So what would I have to multiply 2 by to make it an 8? Well, you'd have to multiply it by a 4. So that's what we're going to do. We're going to choose to multiply negative 2x by a 4. But if we do that, we have to do it to the entire equation. So I'm going to multiply that entire equation. So let me rewrite the top equation first. 8x plus y equals 12. Now, if I multiply the 4, it has to touch everything. So that's going to give me negative 8x. 4 times 3y is plus 12y. 4 times 10 is 40. Now, if you add down and you add your like variables, here's what happens. 8x minus 8x is 0. 1y plus 12y is 13y. 12 plus 40 is 52. Now, the x's are gone. There's nothing there. All we have to do is solve this equation. 13y equals 52. So divide by 13, get out your calculator. The answer is going to be 4. So if y is 4, we have it. Now what they said is I can go back to either one of these two equations, either this or this, put the 4 in for y, and then solve for the x. I'm going to choose to put that 4 of y right there, and then see what x will be. So that gives us 8x plus 4 equals 12. So let's subtract 4 from both sides and get 8. I'm going to divide by 8, and I'm going to get x is equal to 1. So remember, if I were to graph these two equations on graph paper, they would cross at the ordered pair of 1, 4. Now I want us to look at that same example again. We already know the answer is going to be 1, 4. But here's my question. What if we wanted to get rid of the y's instead of the x's? We could have. The rule for this method is they have to be the same number but opposite signs. So if this bottom equation is a 3y, I need to make this thing at least a 3. Even more so, I need to make it a negative 3. So what do I have to multiply y by to make it a negative 3? Well, negative 3. So I have to multiply everything in the equation by it. So this negative 3 has to go and touch all of that. So let's rewrite the new equation. 8x times negative 3 is negative 24x. 1y times negative 3 is negative 3y. 12 times negative 3 is negative 36. And then I'll just rewrite the second equation just like we see it. If we add down and add them together, negative 24x minus 2x is negative 26x. Negative 3y plus y is 0. That equals negative 26 plus 10 is negative 26. If you solve for x, you're going to get 1, which is exactly what we knew would be the answer. So know there's multiple ways you can approach it. Sometimes it's nice to find the quickest and easiest one though. So let's look at this example. They want us to either get rid of the x's or the y's. Now I could do two different methods for this one. I could either choose to get the x's to be the same number but opposite signs. If I do that, I would need to make them both a 4. Well, this guy's already a 4, so to make this a 4, I would need a 2. But it has to be the opposite sign. It has to become a negative 4, so we would multiply this by negative 2. So if we do that, then we're going to distribute this through, and we get negative 4x. 5y times negative 2 is negative 10y. 14 times negative 2 is negative 28. And then again, the second equation I'm just going to rewrite so it's nice and lined up. If you add down, negative 4x plus 4x is 0. Negative 10y plus 2y is negative 8y. Negative 28 minus 4 is negative 32. Solve this equation by dividing by negative 8. Y would be 4. Now, to find the x value, I get to pick where I want to put that. I think I'm going to choose to put the y of 4 back into this second equation there. If I do that, I will get 4x plus 2 times 4 equals negative 4. Simplify. 2 and 4 is 8. Solve for x. I'm going to subtract 8. Divide by 4. X would be negative 3. So the ordered pair answer, they're going to cross if I were to graph them at 3, 4. Okay. Now, I just want to show you, we could have done this a different way. We could have, if we wanted to, chosen to get rid of the y's. If we got rid of the y's, though, they have to be the same number. The only way to make the y's the same number would be to go to this first equation and multiply it by a 2, and go to the second equation and multiply it by a 5. And even more so, a negative 5, so that they'd both be a 10, but one would be a negative 10. If you did that, you would actually get the same answer, just a little bit more work, but it would work. So let's look at this first one here. What makes more sense, to get rid of the x's or the y's? There's two different methods we could do. If we do the x's, they're already opposite signs, so that's good. They have to be the same number. To make them the same number, the number they could have in common would be 6, or 3 times 2. So to do that, I'd have to multiply this entire equation here by the number 2, and then I have to multiply this entire equation by the number 3. Okay, you could do that, it would work. Or you could choose to look at the y's and get them to be the same number, but opposite signs. Well, that's an 8. I can make that an 8 by multiplying it by a 4. They have to be opposite signs, so I should multiply it by a negative 4. You get to pick and choose which one you want to do. I'm going to go ahead and let's get rid of the y's this time. So instead of keeping this stuff here in the blue, I'm going to get rid of that because I'm going to choose not to get rid of the x's but the y's. So to do that, this one's okay. This second one, though, needs to be multiplied by negative 4. Multiply it through. I'm going to rewrite the first equation just so I can see it again nicely. And then do negative 4 times negative 2 would be positive 8x. Negative 4 and positive 2, negative 8y. Negative 4 and 18 is going to get me a negative 72. If you add down 3x and 8x is 11x, the y's cancel out, and then you get negative 77. Divide by 11, the answer is negative 7. To get the y value, I'm just going to take that x and put it right there. So I have negative 2 times negative 7 plus 2y equals 18. Negative 2 and negative 7 is positive 14. I'm going to subtract 14 and get 2y equals 4. Divide by 2. Y is 2. My ordered pair answer is negative 7, 2. I do want to look at one last one. Now this one, I don't have a shortcut. I have to multiply each equation by some number. Now again, I can choose if I want to get rid of the y's or the x's. They're going to be about the same amount of work. If I get rid of the y's, what I would do is make them both a 12. If I get rid of the x's, I could make them both a 10. Let's go for the x's. So the top equation I'm going to multiply by a positive 2. The bottom would be by a positive 5. You have to make sure to multiply that 2 by all 3 pieces and this 5 by all 3 pieces. So we would get for the top 2 times 5x is 10x. 2 times 4y is 8y. Don't forget 2 times 6. It's easy to forget that, but it's 12. A lot of people will just write the 6 still. Next one, 5 and negative 2x is negative 10x. 5 and negative 3y. 5 and negative 1. Add down. X's become 0. 8y minus 15y is negative 7y. 12 minus 5 is 7. Divide by negative 7. Y is going to be negative 1. Okay, if y is negative 1, I'm going to take that answer and I'm going to put it right there, and then I'll solve for x. So 5x plus 4 times negative 1 equals 6. So 5x, I'll do minus 4 equals 6. I'm going to add 4 to both sides. And wrap it up by dividing by 5. If you do that, x is 2. And if I were to graph these, the two lines would cross at the ordered pair of 2, negative 1.